Right, for the second of this week's lessons, we're going to look at how we combine forces together. From your GCSE physics, you remember that most situations there's more than one force acting on an object. You might have done questions about planes flying through the air. You might have had the thrust, you might have had drag, depending what the plane was wearing. You might have had lift, you might have had weight acting. Most situations have more than the one force. In year 12, we're going to restrict ourselves to combining forces which are parallel or perpendicular to each other. But in year 13, we're going to work with the idea of forces at other angles, but it really will be a simple application of right-angled trigonometry. But it's not in this book. Okay, simple idea is that the resultant force is a single force that produces the same acceleration as several forces, blah, 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 blah. The resultant force is the force which summarizes everything that's happening. The resultant force is the sum of all the forces. The resultant force is what you get if you add all the forces acting together. So that symbol there is for sigma, which means summation. In Newton's second law, it's important to remember that F is the resultant force. We're going to have several formulae with F in it. We're going to have F equals ma, we're going to have P equals Fv, we're going to have F equals mu r. In this equation, F is the resultant force, and that's really important. So let's look at a couple of examples. The first one, top left, you pause the video and read the example. Right, if you've got a force 16 to the left, 9 to the right, I always include an arrow to talk about which direction I'm working in. The resultant force is the sum of the forces. A positive one, a negative one, if you're working to the left, which gives an answer of +7, the resultant force is 7 newtons to the left. And then you might go on and use Newton's second law of kinematics. In the second question, we're working in 2 dimensions, and one of them is given in the ij notation. Remember, 5i take 8j is 5 to the right, 8 downwards. That's what 5i take 8j means. It can be replaced by that column vector. It's simply another way of writing that. So what do we have? We have this force which is upwards, which could be written as 0.12. We have this force 8 to the left, which could be written as that, which isn't a good choice of colour because it's obliterated it. So I'm going to go back to using the yellow again. And we have a third force, F minus 3. The resultant force, F, the resultant force is the sum of the other forces. Add them together. 0 and -8 and 5 gives -3. 12 and 0 and -8 gives 4. That's the force. The magnitude is the size of that force. So you apply, let's see if the blue highlighter works here on the black. You apply Pythagoras to the 2 components and you get a magnitude of 5. To decide on the angle it makes, doesn't hurt to do a little diagram, which I snuck in there. So we've got a force of -3, 3 to the left, 4 up. So it's a force that looks like that. It goes in that direction. And I should have put a little arrowhead on there. So let's see if I can use the little pen symbol. So a force that looks like that. The angle with the negative x-axis is that. So it's still the direction. If it just asks for the direction, draw the diagram, give an answer on the diagram of mark theta. The question often will ask for the angle with the positive x direction. how have I got 127? If it's 53 with this axis, if that's 53 there, oh, let's get that to write properly. All right, if that's 53, this will be 127. Take it away from 180. Right. Another example, two children putting a box, blah, 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 blah. Read the example question. Right, how do we do that? Any mention of forces and acceleration and mass is Newton's second law. Right, say which direction you're working in. Newton's second law to the right. Resultant force, the right-hand force take the left-hand force. Mass times acceleration. Okay, I'm just going to pause that. Sorry, I had to go and see the baby sparrows in the bramble bush. Where was I? Newton's second law, force, mass gives an acceleration. Notice in this case it's a one-dimensional problem. I'm not using any of the vector notation. You get an acceleration of 0.95. Because I said I was working to the right, that's 0.95 meters a second to the right. In part B of the question, we've got an acceleration which is 0.7 to the right. So again, Newton's second law in the direction of acceleration. 0.7 goes there, the mass goes there, and the three forces, the 26.4, the 18.8, one positive, one negative, one's to the right, one's to the left, and the unknown force, let's call it F3, 7.6 plus F3, 8 times 0.7 is that, F3 is -2. But the question wanted magnitude and direction. You won't get the marks if you leave it as -2. The magnitude is 2, the direction is to the left, okay? And now here's one in 2 dimensions, going to use the vector notation again. Constant speed, I object to that, okay? And I can talk about that shortly. Constant speed should, in this case, strictly be written as constant velocity, okay? It's simply wrong to say constant speed in this 2-dimensional case, okay? Which implies A is 0, which implies the state called equilibrium, which in my examples I'm going to use that symbol, the identity symbol, then an M, and that implies the resultant force is 0. So the three forces, when you add them together, give 0. And what are the three forces? 3 to the left is -3, 0. 5, 1 is the 5, 1. And we don't know F3. They write it in bold. Right, can I urge you, respect the vector. Underline F3, underline it. Because we know everything adds up to 0, if I move -3 to the other side, -3 becomes +3, 5 becomes -5. Do the same with the J components, do the same with the Y components, J, Y, it's the vertical component, the up component, and you get this. That's the answer to this question, because they wanted the force in vector form. If the question had asked for the magnitude of the force, that would have been the answer. Right, your turn. 11B has 9 good questions. They practice combining the forces. There's 1- and 2-dimensional problems. The 2-dimensional ones use the vector notation, which is either the column vector or IJ notation. It really doesn't matter which you use, okay? Second of this week's lessons, and the homework time, work your way through 11B, try each type of question, particularly the 3-worded ones, where, because they haven't given you a diagram, you draw the diagram. In fact, I'll let you something, whenever I start a mechanics question and say, where do we start it, just say draw a diagram. It's always the case. We're going to use Newton 2 and Suvat because we're still working with forces which are constant. Make sure you've summarised the ideas in your notes. And the crucial one here was the resultant force is the sum of the forces. Send me your answers to 7, 8 and 9. First lesson of the week I wanted 3 questions. Second lesson I want these 3. If you want to submit them together, fine. If you want to do extra, fine. Next week we'll look at naming some forces. Oddly though, of course, the book has introduced the names of forces already, and then we'll look at finishing the chapter off. Right, good luck with all that.